All right, we're going to pick up today continuing working with sine, cosine, tangent, and their buddies. All of those trig functions. Now what we're going to specifically look at today are some special triangles that exist that are used quite often in trigonometry. And I'll be honest, they were relationships that you should have learned last year in geometry. So we're going to take today to review them. And then as we move on in chapter 12 and as we look more at our trig functions, we are going to be exploring ways that they are used. So, taking a look at this situation, first of all, the relationships that we are looking at today, you're going to want to make a note. You want to memorize these relationships. You want to make sure that you memorize these relationships. If you do not know the relationships that exist in these triangles, you're going to have a really tough time with the rest of this chapter. So, these relationships that exist. All right, my first triangle that's a special triangle is a 45, 45, 90 right triangle. In a 45, 45, 90 right triangle, you'll notice that they say the legs are the same length. All right, this is an isosceles triangle for you geometry graduates. Isosceles triangles mean that two legs are the same. So across from each 45, each of those sides is the same length. The second thing they tell us is that the hypotenuse is the square root of 2 times the measure of the leg. Whatever the leg is, I multiply it by the square root of 2 to find the hypotenuse. So what we're going to do, the relationship that we are going to relate is that I don't know the sides that are equal, but I'm going to call them x. So across from the 45's x, across from my 45x, which means my hypotenuse is the leg, the x, multiplied by the square root of 2. So in a 45, 45, 90, the relationship that we're going to mark in there is going to be x, x, x square root of 2. All right, now let's take a look at example number 6. In example number 6, it says solve the triangle. Now yesterday we had a conversation about what it meant to solve a triangle. What does it mean to solve a triangle? Find all the sides, find all the angles. Find all of the sides, find all of the angles. So let's go ahead and take a look at this triangle here in the center. They've told us what type of triangle is it. It's isosceles, absolutely. It's a 45, 45, 90 right triangle. We know that if it's a 45, 45, 90 right triangle, the sides across from these 45 are congruent. And we also know that the relationship that exists in a 45, 45, 90 right triangle, across from the 45's x, across from the 45x, and across from that right angle is x square roots of 2. All right, now besides the angles, what information do they give me in this triangle? The 9, absolutely, they give me this 9. And what did I put there? The x, absolutely. On that side with the 9, I put an x, which means that the x is equal to 9. Now, if the x is equal to 9, what other side do I know? Yeah, absolutely. Segment BC is how much? 9 as well, absolutely. And how much is segment BA? Yeah, x is 9, so for the segment BA is going to be 9 square roots of 2. Fantastic. Bringing back memories? Fond ones, I bet. I see so many smiles. All right. Just a flood of smiles out there. All right, so here we take a look. In triangle ABC on that one on the right, is there anything that I notice? What? Yep, my hypotenuse, they tell me, is 15 square roots of 2. All right, I like that. Is there anything that I know in that triangle? I look at it and I think, oh, I know that. Yep, it's going to be isosceles, but how did you get that? Beautiful. So we know that angle A has to be how much? 45, absolutely. Angle A has to be 45 degrees. Okay, so I immediately realize that this is a 45, 45, 90 right triangle. And in a 45, 45, 90, I'm like a little machine. I'm automatic with this. Across from each 45, those two sides are congruent. Across from each 45 is x. My hypotenuse across from that right angle is x root 2. Okay, now as I'm looking at this, what other information do they give me? Nick, what are you thinking?
X is 15.
Okay, very nice. I like your thinking, because what I think you're thinking here is that they tell me that this side is 15 square roots of 2, and what did I put there?
Well, X is
I put x square root of 2. So I know that x square root of 2 is going to be equal to 15 square root of 2. Now, we're all pretty good mathematicians, so we can see right away that in front of the square root of 2 is x, in front of the square root of 2 is 15. So the x has to be 15. But I'm going to tell you right now, they're not always going to be that nice and easy. So just a question, thinking through mathematically what we do. If I were to solve this for x, what would I need to do? What would I do to get x by itself? What's going on in between that x and that square root of 2? Yeah. So what am I going to do to get x by itself? I'm going to divide by that square root of 2. Thinking about what we know about inverse operations. All right, so what happens with my square roots of 2? They cancel, so we get x is equal to, what happens over here? My square root of 2's cancel, so x is equal to 15. So that is exactly what we already knew, but I just want you to understand the algebra and how we got it. Now, if my x is 15, what else do I know then in this situation? Yeah, my two legs are how much? X here is 15, x here is 15. Beautiful. Anything else so far? All right, let's take a look at another special right triangle. The second special right triangle we're going to be looking at today is a 30, 60, 90 right triangle. A 30, 60, 90 right triangle. Now, you'll notice that in a 30, 60, 90 right triangle, they tell me that the hypotenuse is twice the measure of the shorter leg. The longer leg is the square root of 3 times the measure of the shorter leg. Now, I got a question for you. We all know something about geometry here. And if I look at a 30, 60, 90 right triangle, which side is going to be the shortest side? The one opposite the 30, right? Because the 30 is the smallest angle, so the side across from it's going to be the smallest side. Now, here's the deal. Here's the relationship that I'm setting up. I don't know that shortest side. I'm going to call it x. Across from 30 is always x. My longer leg, which is across from 60, is that times the root of 3. So across from 60, we're always going to write x root of 3. And my hypotenuse is always twice the shortest leg. So across from my right angle, I'm going to write 2x. So in a 30, 60, 90 triangle, across from 30 is x, across from 60 is x root 3. My hypotenuse across from that right angle is 2x. All right, let's take a look at this first triangle down here. Now, as I look at this first triangle down here, what are you thinking to get started? Anything we're thinking to get started here? Nick?
bottom one, right?
Yeah, right here.
So it's 90, 60, and then the top would be 30.
Beautiful, very nice. Angle A has to be 30 degrees because these two have to be complementary. So 90 take away 60 is 30. Absolutely beautiful. Now, we know that this is a 30, 60, 90 right triangle. We know that this is a 30, 60, 90 right triangle. So instinct, it has to be automatic. Across from 30 is x, across from 60 is x root 3, and across from my right angle, my hypotenuse is always 2x. All right, now what information do they tell me? X. They tell me that this side that has the x is 5. So that means x is equal to 5. X is equal to 5. So what does that mean for my segment AC? Absolutely. If my x is 5, then segment AC is 5 squared roots of 3. What does it mean for the hypotenuse in this triangle? 2 times 5, which is 10. Good? All right. Let's come on over here. Another triangle ABC. Now, Jack, what's the first thing you're thinking over there in that triangle ABC?
30, 60, 90.
You bet. I see this angle of 60. I see this angle of 90. I know that because it's a right triangle, these two have to be complementary. So 90 take away 60 means that this angle has to be 30. All right, Kiara, when I see a 30, 60, 90 right triangle, what relationships am I going to fit into that triangle? Oh, wait. We don't have the relationship on here yet. I'm not dividing anything. I'm not... What pieces go where? All right, across from 30 is x. Across from 60 is x squared of 3. The hypotenuse is 2x. Okay. All right. Miss Megan, what do you think? And which piece do they tell me? Yeah, they tell me that 2x is how much? 16. So if 2x is equal to 16, Megan, what do we know? Divide both sides by 2. So x is 8. All right. Yvonne, tell me one of the sides if we know that x is 8. Yeah, across from 30, what do we know about segment CB here? It's the shortest side, so how much is it going to be worth? 8. It's exactly what x is, which is 8. What about segment AC?
It's whatever the short side is square root.
Uh-huh. Absolutely. In this case, what does that mean?
It's 8 square root of 3.
Beautiful. I know that x is 8, so this is going to be 8 square roots of 3. Perfect. Questions so far? All right. Flip on over. Let's do one more together this afternoon. Doing one more together this afternoon. All right. As we look at this one, William, what are you thinking first? Angle A has to be 60 degrees. Absolutely. These two are complementary, so 90 minus 30 makes that 160. So if it's a 30, 60, 90 right triangle, what relationships am I going to be putting on my triangle here, Shia? Across from 30 is x. Good. Across from angle C, across from my right angle is my hypotenuse, which is 2x. Yes, very nice. Across from the 60 is x squared root of 3. All right, Tyler, which side did they tell me something about? Yeah, the 27, segment CB there. And we know that the 27 should be equal to what? What do we have on that side by 27? Absolutely. We have x squared root of 3 on that side, so we know that x squared root of 3 has to be equal to 27. Those two pieces have to be equal to each other. Brandon, what am I going to do to start getting that x?
You take the second power.
Ooh, are you sure?
Third power.
What's going on in between that x and that square root of 3?
You divide square root.
Thank you. They're being multiplied, so I'm going to divide both sides by the square root of 3. So my square root of 3's are going to cancel, and x is equal to 27 over the square root of 3. Miss Morgan, how you feeling about that? I can't? Did I do something wrong? All right, so what do we need to do to clean it up a little bit? It's kind of messy. Yep. Beautiful. I'm going to rationalize that denominator, so I'm going to multiply by the square root of 3 in the top as well in the bottom. So 27 times the square root of 3 is going to be 27 square roots of 3 all over. All right, folks, what's the square root of 3 times the square root of 3? Square root of 3 times the square root of 3 is? 3, because what is 3 times 3? So the square root of 9 is 3. Absolutely. Square root of 3 times the square root of 3 is 3. All right, good to go? Why not? Absolutely. What is 27 divided by 3? 9 square roots of 3. Beautiful. 9 square roots of 3. All right, now, where do I put that, Miss Maddie? Yeah, so which segment is going to be 9 square roots of 3? Opposite of 30. Opposite of 30, segment AC, x. Well, x is equal to 9 square roots of 3. All right, how about segment AB? Natasha, how about segment AB? Beautiful. 2 times 9 square roots of 3, which is? Beautiful. 18 square roots of 3. Any questions with that? Any questions? Bring back memories from geometry? Perfect. All right, set that aside then, please.